part of the Academy of Sciences of Colombia, and to our colleague Jose Andres Corredor Martinez, part of the Climate Change Observatory of Javeriana University. And as I told you earlier today, we have a luxury panel hosted by key people that have allowed for this space to happen and of exchange of informations so we can actually come to different advancements to empower our information systems. And to begin, I wanted to have in this space the concept of why it's so important for us to be sitting down together, to why we've organized this space and why we've invested so much work and energy in sitting different experts here, different sectors with decision-making power here, and to different key sectors in these types of discussions like the academic sector, to be advisors to these types of spaces, and why we've actually created this space. Here I wanted to ask our colleagues from the academic sector, Dr. Hugo and Dr. Javier, to please tell us a little bit about how the different Earth observatories can support the priorities and the challenges at a regional level in terms of health within the framework of health, strengthening surveillance of public health, and promoting different sustainable partnerships within this framework of a health system, which is a tool that allows us to see the big picture, to have a global landscape about the crisis that we're all facing as humanity. So therefore, if you'd like, can you begin? We have several microphones here, yes. Well, I want to echo what Nicholas and Carlos said earlier during their welcoming remarks. Welcome to everybody that is here in this event, which I think is hugely important because definitely the concept of health, which I expect that we can share and co-build amongst all of us that are here sitting down in this table, it works based on a concept that is more comprehensive, which is the notion of just one planet. And that notion of only one planet has only been possible with a vision, a remote vision of ourselves, with perspectives, and based on data, and based on technology. Technology that I expect we can talk about during this discussion, and that we can incorporate to help us solve the fundamental questions that lie before us as humanity. In one of the moments, in one of the most difficult moments that we're going through right now as humanity, we just went through a pandemic that not only left us with millions of sad human deaths that are irrecoverable, and a legacy which is very committed in terms of financial terms, a huge recession that has led us not only to hurt economies, but also new conflicts have arose that we thought these conflicts had disappeared in the past. Connections, the IT connections that we have with nature, informatics connections was a major legacy that the pandemic left us. A small bat, I work with bats in China, a small bat in China stopped the Bogota economy in just a few months. This auditorium was completely empty as all universities were emptied worldwide. And I believe that it went very quickly and that message was forgotten quickly. And we hope that in this dialogue, Nicholas, that via this talk and via these questions that we are going to solve and the contributions of our colleagues here, that we can try to reestablish that necessary attention from the people that are in charge of very important roles, very important work, that putting their eye on the sky, that this eye in the sky that allows us to see the different perspectives. And let me wrap it up with the following. I had the opportunity to live in the Yukuna culture. These people have a festival where they inaugurate the new malocas that represent the universe. And the people come in and they sing. The first that sings is called the gallinazo real. It's called Yuro, this mythical creature. And they sing Yuro, Yuro, Yuro. I am the one that flies the highest, and I can see the furthest, says this indigenous teaching, and that data will help us with decision making that we may need at a local and global level. Thank you. Thank you, Hugo. if you can help us from the technical table by putting up the slides that we've got so that Dr. Hugo can talk a little bit more about the topics. The next one, yeah, perfect, that one. Hugo, tell us a little bit about this. Well, I've brought a few practical examples to the table of research that we've done, and a special greeting to the authors and the colleagues that helped with some of these slides, and you'll see them here, especially Dr. Fernando Trujillo, Federico Mosquera, whom we've had the opportunity to work together and create or use satellite tags, and we captured 24 pink dolphins in the Amazon and the Orinoco River basins, and the purpose was not only to understand biology patterns from these organisms, but the dolphins are the biggest predators in the aqua systems, and in that sense they're the big reservoirs of all the trophic chain. That's where it ends, with everything that they eat, all of their prey, and mercury that we have put into our rivers with the mining activities and extended activities in the two river basins with gold extraction. But also we understood another very important thing with this message. We were very worried about this mercury deriving from gold. And what happens is it was only just a fraction of the biomercury, methane mercury derived from the different activities of deforestation activities is also part of that chain that is affecting not only dolphins, but populations, human populations that are living within this ecosystems at an order of magnitude. Our colleagues from the Ministry of Health know this. Above the minimum thresholds, the maximum thresholds, forgive me, accepted by the World Health Organizations related to mercury exposure. So nature, the first example that showcases how nature is speaking to us in a climate service, forgive me, in an ecosystemic service. I was telling Dr. Robert Gonzalez, I invented a concept that was outside of the box, the concept of bioinformation. So that combination of remote data and the voice of nature, in this case, is helping us not simply to protect and plan the conservation of these organisms, but also to visualize a problem at a human health level as well, which is very serious and very vulnerable populations. Next slide, please, Federico. Forgive me. I remembered Federico, but this work was done with the same team. This is work done in the National University, the Ecology and Modeling Group, led by Dr. Sarmenteras, a great scholar, a specialist in fires, and amongst many other. This mercury has derived from deforestation produced by fires in these areas in the eastern part of the country. And here we're actually seeing the biggest deforestation nucleus that we have in Colombia, the core of deforestation, the area where we're cooking the new problems of nature with all the health problems associated. But this is a solution. This is not a problem. This is how do we use remote data in order to generate better connectivity corridors in organizations and organisms that are key for these ecosystems, like those great carnivores and those great mammals that inhabit these corridors. The next example of how we can actually use these remote data. So we have planning in our land use planning, which is very important, that needs to include these elements related to environmental health. Next slide, please, Nicholas. Can you please put the next slide, please? Yes, that one. Thank you. So this is the most interesting climate laboratory that we have in the region, which is Paraguay, because Paraguay has half of their country is a dry Chaco ecosystems like plainlands, and the portion on the southeast of the country is the remnants of the Atlantic Mata, which are some structured forests similar to the Amazon forest. What you're actually seeing on the screen between this map, more to my right, is the accumulation of the wealth of bats in Paraguay in an area called the ecotoma, which is the middle between the dry area and the wet area. And what we're actually seeing on the map on the left corner is how that accumulation of that wealth is seen in projections to climate change and how it will look in 100 years. A forecast for 100 years. The change that we're interested in observing is not simply that to reduce that we're going to corner and reduce by diversity, but you're seeing the colors here. Observe the colors. Out of 60 arrays that we can have today, where we have each of them in their own locations, we're going to go on to way less arrays. And what does this mean? bats that have never seen each other in the past are going to coexist. What does that mean in terms of health issues? It means that we're going to have a great deal of risks. That's how pandemics are created. And this is being showed by nature today. So we can project the future with the data of today. We can actually forecast the future to see what these possible scenarios of risk will be and work upon these pandemic possibilities or risks. And the next slide. Here, it's also related to land use planning. This is the department that I work with, the state or the Department of the Quindíos. And this is the planning not only of one species, but these are all mammals that jointly are showcasing different patterns of how they're distributed as mammals, how they distribute themselves phylogenetically speaking, who's related to who, and the graphic that we see on the upper right-hand corner for you is how the ranges of distributions are changing in terms of elevation. They're changing elevations, which is a fundamental aspect to prevent pandemic risks, because since they're going up in altitudes and these vectors are going up to other elevations, we're having vectors from arthropods and other microbiosis, and chikungunya and different other diseases are also going up higher. We have a big problem with the yellow fever, which certainly we will discuss at a certain moment, but we have the possibility that exists in this modeling of generating these tools. And finally, the next slide, please, are some slides that are, the next one, please. I'm going to speak about the hantavirus. The hantavirus is related to different rodents. It's distributed throughout the entire region. Each of these different colors represents a different type of mouse, and each type of mouse has a different type of virus. And since the layers change, the virus factor, the virulent factor, and the one that affects us as humans can actually be transferred and extrapolated with unknown factors amongst one species going to another. What can we do with this work? The next slide, please. We have been able to not simply understand where the heat points are for the hunting, but understanding what are the climate elements that participate within generating these possible zoonotic disease possibilities, and how we have the participation. It's not here in the slide, however, but it's in the slide. But however, how those hot points are associated to areas of huge transformation of the landscape because of human activity. And this is simply the point of the iceberg. Just a small example of how we should incorporate this data. We'll wrap it up by inviting you. On Friday, we're going to have an entire panel organized by the South American network of Una Health, promoting a new field called biogeography of disease under the concept of health. And this is a common space where we expect for all the people that are working on geographical data, all of this variety of data, the human side that doesn't represent but that is contained within this, climate data, projection data, the different time series, is how we can unify this to the concept base of the biodiversity that allows us to, biogeography that allows us to understand things, temporalness and space of what is living in this planet. And as you said very wisely, Nicholas, it's changing more than ever. Thank you so much. Thank you.